Hello. Hi everyone. Let's wait for a few more minutes. Can someone tell me whether my screen is visible? That PowerPoint presentation screen is visible? It's okay. Okay, fine, fine. So, can someone tell me? Actually, this is our first class. Subject is soil mechanics and foundation engineering. So, as this is first class, we will first introduce each other. Before that, let me confirm whether can you see the change in slide. Can someone confirm? uh, right, now can you see any question? Yeah, okay. Now so let me here, how many are there? Let's check first. Around 10. Okay, first we will spend first 15 minutes on introducing each other. So let me ask one by one. You can tell or you can ask any doubts. I can ask first Chaitanya. Can you introduce yourself? Where are you studying, or you have? Yeah.
Yes, sir. Yes, sir. Myself, Chaitanya Kumar, sir. Currently, I am pursuing MTech second year in Jawaharlal Nehru Technological University, Kakinada, JNUK.
Okay, okay, fine, nice.
In geotechnical English conservation, sir.
Okay, fine, good. That's great. And next, Manjunada. Manjunath. Yeah. Can you tell me about yourself? Yeah. Okay. 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 Acha, acha, nice. Okay. Next, Rahul Patel. Yeah. Okay. 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 Now, yeah, I can call up next person. But before that, see, when I solve the questions in this session, you can stop me in between, okay? Or else, if you feel, if you want to ask at the end of at the end of solving the question, if you want to ask the question, you can ask. Uh, Actually, we have been given only 1 hour session. So in 1 hour, we have to solve like some fixed number of questions. Like you can say 4 number of questions. So here you can listen in the live interaction, as well as the detailed explanation of the same questions will be uploaded in the website. So the website link will be shared with you, maybe in the next class or next to next class I'll be sharing with you. Okay, you can go through those videos. There will be very detailed explanation. So actually it's a good number of people who are attending. That's good. So, and also now, if you have any doubts regarding what are the opportunities after writing the gate, you can ask, not just in the first class, you can ask in the next class also. There is no issue. But from the next class onwards, we'll be um, focusing more on the solving questions, okay, instead of general discussion. But definitely general discussion is allowed in every class, nothing is like that. And now coming to the introduction part of people, Chaitanya is over and Akshaya Shri. Akshaya Shri, can you introduce yourself? Where are you studying? Or
Good evening, sir. I'm Akshay Sri from Tamil Nadu. Currently pursuing third year from Civil
acha, third year BTech. Okay, nice. Which okay. Next, Aruna Kumaran. Can you introduce? Aruna Kumaran, can you listen me? Okay. Next, Ratanala Sridhar.
Hello, sir. Myself
Ye-
Aruna. I'm from Tamil Nadu, sir.
Okay. Okay. Ratanala Sridhar. Yeah, yeah,
I'm third year. Hello, sir.
yeah, yeah. You can tell me. You can tell me. Go ahead.
Sir, I'm studying third year civil, sir.
Oh, great, great. Okay. So next, Ratanala Sridhar, can you tell me about yourself? Okay. Next, we'll shift to Sudarshan Shinde. Yeah. Good evening. Yeah. Okay. 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 Nice. Nice. Okay. Vijay Kumar S.
Hello, sir.
Yeah. Hello.
Sir, I am Tamil.
Yeah.
Being pursuing what
Okay. Fine. Fine.
pursuing a BTech in geotechnical.
Nice. 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 Good. Vikas Kumar.
Hello,
Yeah. Vikas.
good evening, sir.
Yeah. Yeah. Good evening.
My name is Vikas Kumar. I have recently completed my BTech in Civil Engineering from last year from Naresh Technical College of Engineering,
Yeah.
Hyderabad, Bihar.
Okay.
I
Nice.
have attended NPTEL GS
Okay.
third year and fourth year, but I have not cleared cut off.
Mm. Okay. I think this will be useful for you. I hope. Yeah. Next.
Yes, sir.
Yeah. Next, Vriju Sadhukan. Vriju Sadhukan, are you there? Okay. No issues. So, shall we start the session? Or do you want to ask any questions from your side? You can ask, no problem. Feel free to ask anything. Any general discussion is also fine. And one more thing, is there anyone left who has to introduce themselves? Here I could see only few people. I could ask, like there are 12 people, maybe 2 of them are mine only. Then Ratnal Sridhar, come, yeah, Sridhar, tell me.
Sir, my name is Ratnam Sridhar.
Yeah,
I'm
you,
studying in third year, sir,
oh,
geotechnical engineering.
oh, mechanical.
Hello, sir.
You are from mechanical department.
Yes, sir.
So how do you need this?
Sir, there is no class for mechanical today, sir. That's why
Okay, okay, that's fine. No
I'm
problem.
choosing second.
No problem. No problem. No problem. No problem. You can see and
Why don't you get to crack directly?
what? Can you come?
Why don't you enough to crack the gate?
Yeah. If you give dedicated time every day, definitely you can crack the gate. There is no issue. Even 3 months are enough. But the thing is, how are you preparing? How much rigorous preparation you are doing? That is important. Yeah. Okay. You can mute yourself, Sridhar.
Okay, sir. Sir?
You can mute. Okay, I muted you. No problem. Hello, Sridhar. Yeah. Okay. No problem. No problem. Yeah. Let me introduce first. My name is Singam Naresh Kumar. I am from Hyderabad, and I am doing PhD in Civil Engineering Department, and with the specialization of Geotechnical Engineering. in IIT Bombay. So that is all about my introduction. I have completed my MTech also in IIT Bombay, and my BTech is not BTech, actually it is Bachelor of Engineering. It is from Usmania University campus from Hyderabad. This is all about my introduction. So you can feel free to ask if any questions are there. Like Sridhar asked, how many days you need preparation. Just like that, you can ask any question. I'll give you 2 more minutes, 3 more minutes. You can come up with these kind of any doubts. So you feel free to ask, and it is very good interactive session. Not just only problem solving. You can get the motivation also. You can ask me about my things so that you will understand how to overcome the situations. Anything is fine. You just ask me. So I'll be waiting. I'll be listening. Happy to listen those things. Any doubts? So Suyavasan. Yeah, Rahul. Yeah, tell me.
I have one doubt regarding the standard proctor.
Okay.
Is there any standard proctor method in which actually we only getting one curve, one peak value?
Okay.
Yes.
Yes.
But yesterday we are performing in geotechnical lab. We are
Okay.
performing on the sandy soil
Okay.
granular.
Okay.
We are getting three peak value. After that we are getting variable decreasing. Is that the test is correct or not?
And definitely not, because because you can't get three peak values. It is a manual test, right? You are doing yourself. So while taking weight, while compacting the soil, you need to compact as per the procedure which is given in the Indian standard codes. Okay.
Yes, sir. We are
Yes, I understand.
follow all the procedure as per the ISO.
Yes, I understand. I
But
understand.
when the value starts increasing or decreasing, this process I'm going with
So
little bit confusion in me.
So you have got three peak values means, how do you say that there are three peak values? One of them, like all are equal. You are saying all are equal.
No, no.
If all are not equal, how can you say there are three peak values? There should be only one single value which is higher than any remaining value. That is called peak. Yeah.
First value was 1.94, another was around 1.98, and
Yes.
last one 2.01. After that, the value change to decrease.
Then 2.01 is the peak value among those three. Then you draw the curve, smooth curve. You draw the smooth curve. You just see the peak of the curve. Okay. It will be nearly more than 2 or nearly 2. Okay. It cannot be less than the 2 point whatever value you set at the end. Okay.
In those between value, one value is decreasing, then increasing. That when I have said 1.98,
Yeah.
after that, yeah, decreasing. After that, 2.01, as we got this value.
Then you have got 2.
Yeah.
Okay. I think there will be, see, it is finally a test which is done by a human. There will be manual errors. And the thing is, the 1.98, 1.94, they are almost equal to each other, right? So I think somewhere the the effort which you have given in compacting the soil in the proctor may be little bit more when you are doing first test. Okay.
Yeah,
The
soil test and
Yeah, that's the thing. So you have to take all those into picture. You again perform on the same soil. Okay, only single person this time. Okay, you take care of every manual errors this time, and then you check. You will definitely get a good curve. uh, I Yeah. Now new people have come. Let me check. Others Sony. I think Sony is a new person who joined now. Can you tell about yourself, Adarsh Soni. Which year you are studying in, or have you passed out from the BTech? You can tell. Adarsh Soni or Aruna. Aruna is done. Rajashibhai. Bela. Rajashibhai. Can you listen me, Rajashibhai? Okay. Then let me check. Parthu. Parthu. Okay. Next, Sagar. If Sagar is there, can you introduce yourself? Yeah. Tell me where are you studying, or which you have come, whether you have completed BTech or MTech, whatever. You can tell about yourself. Where are you from? Sagar? What happened? Can anyone reply to me that am I audible? Yeah, fine. Thank you. Next, Suya Vasan. Can you introduce yourself? Yes. Okay. Where? Can you come again? Okay, fine. Okay, people, I'll start now. So, shall we start? Can somebody reply yes? Shall we start solving questions? Okay, thank you. So, you can stop me in between, but probably I hope you won't get any doubt while solving the question. I hope it, but if you still get, you can stop me and ask. Okay. So can you see the question here? So once you confirm if you can see the question, I will just start the solving solution. One of you can, yes, okay, fine. So here this question is from the GATE 2022. The set number 1 means forenoon, in the morning session, the civil engineering paper. Question number 18 of 1 mark from the civil engineering question paper we are solving. So here we will read the question first. We will solve it like sigma V dash and sigma H dash. They denote effective vertical stress and effective horizontal stress respectively. Which one of the following conditions must be satisfied for a soil element to reach failure state under Rankine's passive earth pressure condition? Just a minute. Somebody wants to join, I think. Okay, let me admit. Okay, now here we need to see this first, Rankine's passive earth pressure condition. So now what is earth pressure first? Before that, before Rankine's theory, we need to understand what is earth pressure. Earth pressure involves generally in case of retaining walls. Okay. Yes. So now, retaining walls are to support the soil which cannot stand on its own. So this is soil or earth material. You can call it as earth material or soil. So now the pressure from the soil and in turn pressure from the soil to the wall and in turn from the wall to the soil. So this pressure is called, it is in between retaining wall and the soil. So that is the reason why it is called as earth pressure, because which is finally generating from the earth. So that is the reason why it is called as earth pressure. You all of you have actually the prerequisite for this session. You need to know little bit basics of soil mechanics, where these kind of things involve. So I cannot teach the syllabus, right, as a BTech teacher or BE teacher. I can solve the question. That's why the prerequisite is little bit you need to know. Anyway, so coming to the Rankins theory, which will deal with the earth pressures and all, the assumptions which involve, if you take any standard book, the standard books are Soil Mechanics by Gopal Ranjan, Soil Mechanics by Arora. These are standard books of soil mechanics. You can go through the Rankins theory assumptions, all the assumptions, but I don't want to mention all those assumptions in this class now. But I can give you few assumptions, one or two assumptions, like this retaining wall which is supporting the soil. This is also called as backfill. Okay, this is also called as backfill. This wall is smooth according to the Rankin. The wall is smooth. Also, this soil material is cohesionless soil material. Okay, that means what is cohesionless soil material? So what is first assumption? Cohesionless. And what is second one? The retaining wall surface is smooth. Okay, and there are remaining other assumptions which are not related to this particular question, by the way. So cohesionless soils, here the word itself is saying that cohesion is not there, that means C equal to 0, right? It has only, the soil will have only friction angle, it is not equal to 0, it has some value. Now we will so now we will solve. We will see what are the different kinds of pressures which will, sorry for the dirty diagrams, but the concept should be clear at the end. Now this wall can move away from the soil, right? Due to the pressure which is applied from the soil, this wall can move this side. And also a simple example I will give you, that there is a retaining wall, the earth material is up to this height on the right hand side, and this side only this much height. So if the material is same, then definitely the pressure from this will be more than the pressure from this side, right? Then wall definitely, yes, 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 I am drawing something. What happened? Acha, okay, just a minute. Can you see now? You can see the diagrams? Okay, fine. Okay. So I think I need to repeat again. So this is the retaining wall. This is the soil, and because of the soil pressure, retaining wall moves in this direction, right? So depending upon the design, of course, you can design the retaining wall so that it cannot move at all, and also you can design the retaining wall so that it can move in this direction little bit because of the pressure. And one more case here, if you see the retaining wall which is supporting the soil from two sides, from the left and right side. So here if the soil is same material, the pressure from this side will be more than this side. Because of that, retaining wall can move in this direction, right? So when it is moving in this direction, this soil will be under compression. When it is moving in this direction, this soil will be under tension, right? And there is at rest position of the retaining wall. In that case, the soil will not move at any direction. So now first one, the pressure which is exerting from the soil onto the wall when the wall is moving away from the soil is called active earth pressure, right? And when the wall is moving towards the soil, the pressure which is exerted by the soil onto the retaining wall is called passive earth pressure. And when the wall is at rest position, that means wall is not moving at all, then the pressure from the soil onto the wall is called at rest earth pressure. Okay. Now here if you see the question is dealing with only passive earth pressure. So we have to see the multiple choices which are given. What exactly is asked, we will understand now. Here the question is asked about whether sigma v is less than sigma h, whether sigma v is more than sigma h, or whether they are equal to each other, or sum of them equal to 0. At which point when it is reaching when the soil element behind the wall is reaching the failure state according to this theory. So at that point which stress is more than which stress? First of all, we need to know what is sigma v, sigma h. This is given in the question itself: effective vertical stress, effective horizontal stress. Let's move to the next slide again. So effective vertical stress, you can take any soil element. I am taking a big element, by the way. So effective vertical stress is coming due to the overburden pressure, which is equal to gamma into h, that is denoted by sigma v dash. Now this soil will be exerting a horizontal pressure, of course, onto the wall, and that in turn the soil itself is subjected to some tension or compression. So now as we are dealing with the passive earth pressure only in this question, now let me draw another. So when now in the passive condition, wall is moving in this direction. So when the wall is moving in this direction, what happens? Soil gets compressed. When the soil gets compressed, so at one point soil has to fail under shear, because you are applying the load onto the soil. So at that point it fails under shear. So this is called wedge. So this is called failure plane. Along this plane the shear stresses will reach to the shear strength, and then it will fail. This wedge tries to move horizontally, in turn little bit above. So finally the pressure from the wall, if you take any soil element, the pressure from the wall will be horizontal, because the movement is horizontal, and this element is also subjected to a vertical pressure. So now to complete equilibrium or plastic equilibrium state of the soil element, now the soil element can be taken. So I am magnifying the, so there are all compressive forces. Vertical force is downward due to gravity, due to the movement of the retaining wall, as it is passive, it is applying compression, right? Now this pressure which is coming horizontally is called sigma h dash, this is called sigma v dash. So which one is more, whether sigma h is more, sigma v dash is more, when it is reaching failure? That is what we are studying right now. Okay, for that you need to understand the concept of the Mohr circle first. So let me explain roughly, briefly, what is Mohr circle and what does it define. Okay, so you take any soil element, you apply any kind of pressure, okay, any kind of loading. There may be some shear stress along this plane, or there may not be any shear stress along this plane, fine. So anyway, now when you are applying any kind of loading onto the soil element, there are infinite number of planes which are existing in this soil element, right? There will be infinite number of planes. So this is also a plane, horizontal plane, vertical plane, horizontal plane, again vertical plane, this is inclined at some degrees. Okay, there are infinite number of planes. So I am focusing only on one plane, let us say, because of the load. Because of the load which is applied on the soil element, finally it fails. Okay, before failure or after failure or during the failure or at any point of applying the load, what happens? Every plane is also subjected to some normal stress and some shear stress. Because of the loads which you applied on the element, every plane is subjected to some combination of sigma and tau. Now if you take sigma on x axis and tau on y axis, now at any point of loading, so let us say at t equal to t1, at that point this is the condition of the soil element. So every plane has some different combinations of sigma and tau. So if you take all the sigma and taus, sigma 1 comma tau 1, sigma 2 comma tau 2, sigma 3 comma tau 3, like that sigma n comma tau n, take all the points and draw in this plane. Just put those points, because sigma and tau, this is x and y. So if you put all those points, you will get a circle. Of course it is full circle, but generally it is shown by half circle. Okay, every point on this circle will define a combination of sigma comma tau, right? Because it is in this plane. So that sigma and tau is on one plane in this infinite number of planes. This point represents one plane, this point represents one plane, like that it is the condition of the soil element. Now what we are talking about here, we are talking about the at the failure of the passive in passive condition, whether sigma h is more or sigma v is more, we don't know. We'll just solve it now. So now anyway, taking that soil sample which is behind the earth, behind the retaining wall, it is subjected to only vertical pressure. If you see, only vertical pressure, there is no shear stress, only vertical overburden pressure, and also from here there is no any shear stress. So when there is no shear stress on any plane, that plane is called as principal plane. Whether it is minimum or maximum normal stress, it doesn't matter. If there is no shear stress, if it is 0, then those are called principal planes. Okay. Now the soil element behind the retaining wall is having principal planes. So we know the principal stresses which are defined by sigma v dash and sigma h dash, correct? Now I'll draw how here. Let us consider first two conditions. What are those two conditions? Sigma h dash can be sigma v dash, or sigma h dash can be less than sigma v dash. Out of these two, one will be the answer at the failure condition. Now one more thing, in this plane only, along with Mohr circle, this Mohr circle will tell you the state of the soil element. Along with that, there is a failure envelope. This equation is shear strength equal to cohesion plus normal stress into tan friction angle. This is the equation of the line where C is 0, because cohesion less material we are dealing with because of the Rankine's theory. So because of that, S equal to sigma tan phi. This is S is nothing but tau, shear stress and shear strength both are on the y axis. Now y equal to x into m. So this is a straight line which is passing through the origin. If C is there, it would have had some intercept. As the C is 0 here, it doesn't have any intercept. Now what is the angle of inclination for this? This is phi. Now this is failure envelope, this is Mohr circle. What here we need to understand, when the soil element is subjected to the loading, at one point of loading the Mohr circle is representing like this, but all stresses, if you see, all points are well below the failure envelope. So when the Mohr circle, that means the state of the soil sample, is well below the failure envelope, it will not fail. So what should you do? If you are increasing the load, what will happen? The stresses also will increase. Because of that, the circle will develop like this, because the stresses increased. So at one point, at one state of the soil sample, the Mohr circle will touch the failure envelope at only single point. As I told you, that what is that single point? The single point is the state of stresses sigma comma tau, which are on particular plane. When that particular plane is reaching these stresses, which are equal to the failure envelope stresses, that plane will fail. If one plane is failing in the soil element, that means total soil is failing. So that is how failure is defined. Now to draw neatly, I will tell you. So this is Mohr circle at the failure, and this is failure envelope. This is touching here. This is sigma f and tau f. Sigma tau. What is f at failure? Normal stress at failure, tau shear stress at failure on that particular plane. This is only on one plane along which it is failing. This is how the Mohr circle concept will be. Now we will enter into the solution now. So I'll take two conditions here. What is the first condition which we are talking about? We will start with sigma h greater than sigma v dash. Okay. Now here, to draw the Mohr circle, how should we start? First we will know the drawing of the Mohr circle also before solving this question. See, if you see any extreme ends of the diameter, so if you take the diameter like this, these are the extreme ends of the diameter. These stresses are the stresses on two planes, two different planes which are perpendicular to each other. So to draw the Mohr circle, what should you do? You have to select two perpendicular planes, and those stresses, suppose here what is the shear stress? It is 0, and what is the normal stress? Sigma v dash. So sigma v dash comma 0 on this plane, and what is the another plane? This is sigma h dash comma 0. 0 is what? Tau. Sigma h dash. Tau is 0. Tau is 0. This is the one point. This is another point, and these two are the points on the perpendicular planes. Now if you take and put those points in this plane, those are the extreme ends of the diameter. If you know the extreme ends of the diameter, you can complete the circle by drawing perpendicular bisector. So that is how the drawing of the Mohr circle will exist. Now we will move towards the, this is sigma v dash and this is sigma h dash. Okay, sigma v dash. Now what is the condition, initial condition of the soil before failure? This is the initial condition of the before soil before failure. Sigma h dash is greater than sigma v dash. So sigma h dash is somewhere here. Okay, sigma v dash is somewhere here. Okay, now sigma h dash and sigma, these two are the planes which are principal planes because there is no tau, as I explained already. So this is sigma h dash comma 0, you can say this is sigma v dash comma, this is first condition. So you can complete Mohr circle, right? Now this is Mohr circle. Now you can, if suppose this is failure envelope, so, okay, anyway, no problem. So this is the failure envelope, right? Now what is changing in this? Sigma v, will sigma v change when the retaining wall is moving in this direction because of the passive condition? Will sigma v change? It doesn't change because height is not changing, the gamma is not changing. That is the reason why sigma v is always constant, that you should remember. So the change in pressure will happen only in horizontal direction from some value before movement and to the some value at failure. So it changes from one point to another point. Only sigma h will change. You should remember that. Okay. Now sigma h is changing. So here, as the sigma h is changing from one, why did I draw this Mohr circle well below the failure envelope? I told you that it is initial state of the soil before failure. That's why it is well within the failure envelope. Now what happened, as the wall is moving towards the soil, sigma h is increasing, right? So when the sigma h is increasing, it will reach to this point, new sigma h, but sigma v will be at that point only. Now let us increase the, let us draw a Mohr circle according to the new state of the soil element. Now it again, sigma h is again increasing until failure. So sigma h will go here, but sigma v will be here only. Then complete a Mohr circle. So sigma h and another sigma h, finally at one point the failure, the Mohr circle, the state of the soil sample will reach a point where this Mohr circle is touching the failure envelope. At that point it will fail. So at the end, sigma h dash at failure, at the end if you see, this is greater than sigma v. Sigma h is greater than sigma v dash, right? Now we will start with another condition. What is that condition? First we will, initially we take sigma v is less than sigma h. Now we will take sigma v is greater than sigma h. Okay, we will start like this. Okay, sigma v is now here, let us say. Now this is the initial state. Okay, this is the Mohr circle, right? Sorry, this is the failure envelope. Now what is changing? As we have discussed already, only sigma h will change, and that too it will increase, it will not decrease, because wall is moving towards the soil. So what will happen? Let us take sigma h is here because it is increasing. Sigma v will not increase. Now draw a new Mohr circle. Mohr circle size is decreased now. Now sigma h new position is, let us say, here. Again it is decreased even more. Now at one point sigma h will be equal to sigma v. That is just a point. It is still well within the failure envelope. Now sigma h has crossed. Now new Mohr circle. Now it is here. Like that sigma h moves until a state of the element, that means Mohr circle, reaches failure envelope. Now new sigma h will be here. At that point it is failing. So at the end again sigma h is becoming sigma v, right? So what we understood, for the passive condition, when the soil is under compression, sigma h should be more than sigma v, then only soil failure will happen. So that is what here the option A is the correct answer. Any doubts? Sigma h is greater than sigma v is nothing but sigma v is less than sigma h. I hope everyone understand. So shall I move to next question? Am I audible? Can someone reply? Yeah, I hope the problem number 1 is solved. So let us move to problem number 2. We have less time. We have only 20 minutes more. Now the problem number 2 is the question number 40 in the set number 1 only from the civil engineering gate 2022 civil engineering paper. So there are two groups which are given, group 1 and group 2. We have to match them. So first we will go through the group number, things which are given in the group 1. So the options, one is normally consolidated soil, another one is quick clay, and another one is sand in critical state and clay of high plasticity, right? So anyway we have to go through group 2 also, so that we will understand actually what is related to what. A preliminary understanding will happen. Sensitivity greater than 16. Generally sensitivity will be talked about clays, right? Generally for clays. And dilation angle, generally it is for sands. Even for soils you can, all kinds of soil, but generally for sands, dilation angle. And liquid limit, it is for any kind of soils, sand or clay anyway. And over consolidation ratio, that is also for any kind of soils. A preliminary understanding is required before matching them. You can't just go through group 1 first and directly matching with another group 2. Go through all the options first, then let us see how can they match, how can they be matched. So first we will understand one by one what is normally consolidated soil. First one is what? Normally consolidated soil. So normally consolidated soils are defined by when the soil is when the current overburden pressure in the soil is the maximum overburden pressure which it has been subjected to. That means the current one itself is the maximum that the soil has ever been subjected to. That is called normally consolidated soil. So it is in connection with this, we will talk about over consolidated soil also. What is over consolidated soil? The current overburden pressure is less than the pressure which it has been subjected to in the past. At one point, let us take a soil. So this soil, there was a building whose loading is, or building or any block or something, anything, you can say 1000 kPa, let us say. So now building is demolished. Now what is the vertical pressure on this soil at this point? If building is demolished, it is 0, but this soil is subjected to 1000 before. Okay, that is the reason why this soil is called over consolidated soil, OC soil. So now if it is subjected to, again the construction again restarted, now it is 1000 kPa, again it is restarted and it is equal to 1000. So the past history and the current history is 1000. Suppose again another floor is constructed which is of 100 kPa, let us say. Now it is how much? It is now 1200 kPa. So has soil been subjected to 200 before? No, it is being subjected to 1200 right now. So now it is called NC soil. The same soil can behave like OC and NC depending upon the pressures at that point. So that is how. So normally consolidated soil is defined as the current overburden pressure is equal to the maximum. So now what is the definition of OCR? OCR is ratio between the maximum stress it has been subjected to, soil subjected to, and the current overburden pressure. Current overburden pressure soil is being subjected to. Okay, the ratio of these two is OCR. Now OCR for NC, normally consolidated soil, we understood just now, both are same, maximum and current. That is the reason why it is equal to 1. And OCR for OC soil, over consolidation soil. So current one is less than the maximum one which it has been subjected to. That means the numerator is more than the denominator. It is greater than 1 always for OC soils. Now let's check. Normally consolidated soil is sensitivity is not related to that. Over consolidation ratio is 1. So now 1 can be related to yes. Now, for the time being, let us see and let us understand remaining. What is the next one? Quick clays. So quick clays can be categorized by using sensitivity. Okay, first we should know what is sensitivity. Sensitivity is the ratio between intact strength of the soil, intact strength of clay. Generally sensitivity is dealt for the clays. Intact strength of the clay to remolded strength of the clay. So what is intact strength? First we should know that if soil is undisturbed, if the clay is undisturbed, the strength which it can possess, that is called intact strength. Now you have disturbed the soil, the clay is disturbed finally. So you have disturbed to such extent that the strength is getting decreased because of the disturbance. So finally strength will reach a constant value beyond which it will not decrease even though you are disturbing, beyond the disturbance which you have done just before. It will reach that final minimum strength it can possess after the disturbance is called remolded strength of the clay. So if you take the ratio, that is always greater than or equal to 1, because intact strength, remolded strength cannot be more than intact strength. If you don't disturb it, that the final maximum strength is called intact strength. So that is the reason why it can be greater than or equal to 1. Now coming to the quick clays, there is a range actually. If it is 1, what does that mean? The sensitivity value is 1. What does that mean? The intact strength and remolded strength are both are equal. Even though you are disturbing the soil, the strength will not decrease. Then only you will get S equal to 1. That is the reason why you called insensitive soils. Insensitive soils. And there is another range like in between 1 and 2, in between 2 and 10, like that. Insensitive soils, sensitive soils, medium sensitive soils, highly sensitive soils, like that. When S is, sorry, S equal to 2 to 10, 2 to 10, when S is greater than 16, those are called quick clays, because they get disturbed just like that. When you start disturbing the soil, because of the sensitivity, it will disturb easily and it will lose most of its strength. So that's how. Now since quick clays sensitivity is greater than 16, that's how it is, it can be related. 2 is P, 1 is S, 2 is P. Now what is 3, what is 4 meaning? Sand in critical state. So first of all we will know, this is second one and this is sand in critical state. If you take dense sand, there is dense sand and loose sand. Okay, let us take volumetric strain, delta V, this is plus, this is minus. Dense soil is already packed, the particles are packed to each other, and loose sand they are very free. So here just by labor knowledge only we can understand, when there is a loose sand, when you apply the load, when it is subjected to shear, what will happen? The volume will decrease, because it has lot of voids, it can decrease. Whereas dense soil is already packed, when you are shearing the soil, the dense soil will, the volume will increase, that is called dilation. So the dilation for the dense sands is positive, like the volume, change in volume is positive. So if you say like the change in volume is positive, but at one point when the shear, when it is subjected to the shearing, it will reach a point where delta V, there will not be any change in volume, the volume will be constant. So delta V will be same at that point. So from here to here delta V will be 0. So now the dilation is measured in terms of angles, dilation angle. If you take any point on this, at this critical state is means what? It is at failure. So if you take any point, if you draw a tangent, the dilation angle, the angle is 0. So that's how you can take it as dilation angle is 0, 3 equal as Q. Then clay of high plasticity. Now there will be high plasticity and medium. Somebody wants to join, maybe? No. Okay, medium plasticity and low plasticity soils, low plasticity clays. So especially these high plasticity, medium and low plasticity clays, they depend upon the liquid limit. When the liquid limit is greater than 50%, they are regarded as high plasticity. When it is in between 35 and 50%, they are regarded as medium plasticity. And when it is less than 35% W, that is regarded as low plasticity. So if you see this clay of high plasticity R, anyway logically SPQ then should be R, but you need to know the meaning of everything. SPQR, SPQR. So A is the answer. Okay, so is there any doubt, or shall we move to third question, because we have less time? By the way, still no problem, you can ask any doubt if you have in the previous question. So I am again asking you guys, am I audible? One of you can confirm. Yeah, thank you. Shall we shift to the third question? Okay. So let's read this. This is the question number 54 from the set 1 again, Civil Engineering Gate 2022. So we'll read the question first. A square concrete pile. Square concrete pile means what? The cross section is square. Okay, don't think that everywhere it is square, only cross section is square, the pile, and whose length is 10 meters. It is said that the length of the pile is 10 meters, and it is into a deep layer of uniform homogeneous clay. Average unconfined compressive strength of the clay determined through laboratory tests on the undisturbed sample extracted from the clay layer is 100 kPa. if the ultimate compressive load capacity of the driven pile is 632 kilonewton, the required width of the pile is how much, how many mm? It should be in integer. Okay, now it is a numerical problem and there is fill in the blanks. That means you have to solve and you have to fill the answer. There is no multiple choices. There are no multiple choices, and extra information is given. NC is 9, which is called as bearing capacity factor, and addition factor alpha is 0.7. Okay, let's solve this first. Here first let's draw the diagram nicely. I apologize for the bad diagrams because it is very difficult to draw in the writing pad. I am not drawing on the screen directly, I am writing on some black writing pad. Anyway, so what is the given data? Let's note down given data first. Okay, we need to understand the question by writing the given data. So length is given 10 meters and clay is uniform. Clay is uniform. What is uniform? Means at every point, at any depth, at every point, the shear strength value is same. That means SU is constant at every point. Okay, homogeneous clay. What is SU? By the way, SU is undrained shear strength. Okay, this U is referring undrained and S is undrained shear strength. I'm just writing like that. I don't know whether it is undrained or drained at the end, but I'm writing for the timing SU. So average unconfined compressive strength of the clay is 100 kPa. Unconfined compressive strength is not the shear strength. You please remember that. It is denoted by QU is 100. Unconfined compressive strength it is, not the shear strength. SU is shear strength. So how SU and QU are related, I will explain now. And if the ultimate compressive load capacity of the driven pile, so pile is having some compressive capacity which is denoted by QU. Let us say Q of the pile is the compressive load capacity of the pile. Okay, now what is the required width of the pile? So that means this is, let us say this is the width, let us take this as B. Okay, because it is square and length is 10 meters. So this compressive load capacity of the, actually ground level will be here because the pile is inserted, right? So ground level will be here. So now we need to find out B so that its compressive load will be equal to 632 kilonewton, right? The compressive load capacity is 630. So for this much capacity, what should be the width of the pile? That is what we need to find out. So we need to know what is the formula for compressive load capacity of the pile. So before that, the mechanism of the pile will be, you just take the front view of the pile. Okay, when there is a load from the building, okay, where from the stresses or reaction will be developing from the pile, for the pile. So this soil will give friction. Okay, this soil will give the friction from the surface of the pile. That is also one resistance, and also from the bearing area. From these two, the pile will have the strength. That strength is given as 632. Now from this concept you can write the formula. One is bearing resistance plus frictional resistance. Okay, frictional resistance and bearing resistance, from both it will have the capacity. So from this we can derive the formula. Bearing, so if area is square cross section, right? So there is some area here, that is, let us take this as AB. Okay, area into the pressure or the strength, that is shall we okay, here if the C cohesion will be equal to the shear strength, okay, Cu undrained, in case of undrained and clays, cohesion will be equal to S, because S equal to C plus sigma tan phi, and phi is 0, that means this parameter is 0, S equal to C. Anyway, the bearing resistance can be calculated using the cohesion value. From the cohesion only it can impart some strength. What is, how, that C, but it can't give total C as its strength. There is a bearing capacity factor which should be multiplied so that you will get the bearing resistance, that is NC. CNC is the bearing resistance, AB is the area, so finally it's a load capacity in terms of load, NC, this is C. Now frictional resistance. So if you take the surface area as AF multiplied by the frictional resistance, so here also there is shear strength, again C only, but the C is in between two soil particles, right? The strength is in between two soil particles, not in between this concrete and soil. So that will be less than the cohesion value, that is reduction or addition factor, that is alpha into C. If you multiply the alpha with Cu or C, you will get the net strength along the surface. The strength along the surface multiplied by the surface area, the strength at the bearing multiplied by the bearing, you will get the total load capacity of the pile. So now let us, what is AB here? B into B square, right? Because we don't know what is B. And then what is C? C also we don't know. C is nothing but S, right? C, we don't know what is that. Let us see first. What is NC? NC is 9, which is given in the question. Okay, and now next, what is AF? So if you see the diagram here, what is surface area? This is one surface area, this is one surface area, this one and this one. There are 4 surfaces around. So each surface area can be taken as B into L, 1 BL, 2 BL, 3 BL, 4 BL. Finally, there are 4 BLs. Sorry, 4 into BL. So what is L here? L is 10. 10 is given. So 40 B is the AF. So what is alpha? 0.7, I think, right? 0.7. And what is C? C again we don't know. But what extra is given in the given data? That is Q. We need to find out S or C from the Q. So, and QU is what? If you see, QU is ultimate compressive load capacity. Sorry, I am very sorry. Unconfined compressive strength. Unconfined compressive strength means what? The unconfined compressive strength is done on a soil sample which is not confined by anything. So there will be a cylinder, so in which it is not confined by any pressure. The only deviatoric stress will be applied from the top and bottom. So then the soil gets failed. So before applying pressure, there is no pressure. Still the soil is withstanding on its own. It can happen only in clays. And this test is done only under undrained condition. It cannot be done in drained condition. That is the reason why whatever is unconfined compression test, unconfined compressive strength is nothing but only undrained strength. Okay, now which is given? QU is given. QU is what? Simply compressive. Simply compressive. This is QU. Under some QU, it is failing. But what is shear strength of this clay? How to find out? Let us see. We already discussed just now. We already discussed Mohr circle concept and also failure envelope concept, right? So coming to the failure envelope, here S equal to C plus sigma tan phi. let me take another slide here to explain you guys. Okay, so here S equal to C plus sigma tan phi. As this is clay, this term is 0. Now S equal to 0. How to draw this line? This is the Mohr Coulomb's failure envelope. That means y equal to some constant, y equal to C. This is S, this is or tau, and this is sigma, right? Now y equal to C, that means S equal to constant, some constant. It is horizontal, right? Failure envelope is horizontal for this clays. And the Mohr circle, if you draw, where can this touch? At only single peak point it will touch, right? Can you draw a half circle below this such that it can touch anywhere other than this peak? No, right? There is one peak point. At that point only this horizontal line can touch. Now here, if you see the sample does not have any sigma 3 or sigma horizontal. It has only sigma V, only vertical pressure, because it is unconfined. It is not confined from anywhere, and there is only one force, that is deviatoric stress, which is applied from the top. Now to draw that Mohr circle, new fresh Mohr circle, this is 0, sigma 3 or sigma H is 0, right? And sigma 1 you can take it as sigma D, deviatoric stress at the failure. Okay, at the failure it is still 0, but it is having some value. Now there is no shear stress on any plane because it is completely unconfined. So here 0 comma 0, this plane. And what is about this plane? It is some sigma D, or let us say sigma 1, which is equal to sigma 1 comma 0, tau is 0. Now these are the 2 points on 2 perpendicular planes. I explained, to draw a Mohr circle you need 2 points on 2 perpendicular planes. Now one is 0 comma 0, another one is some value, you can say sigma 1 dash comma 0. Now you draw a Mohr circle, right? And what is the failure envelope? Is horizontal, right? Because phi is 0. Now this total intercept is cohesion, right? This total intercept is cohesion because it is y equal to C, S equal to C. So here if you remember, the unconfined compressive strength, which is QU, is nothing but vertical compressive strength, simple vertical, and that is given as 100. If you remember, that means what? Sigma 1 is 100 here, 100 comma 0, 100. If you know the diameter is 100, what is the failure point? What is the C value here? It is half of the 100. Why it is half of the 100? Because it is radius. It is equal to radius. The peak point is equal to radius, and because it is diameter. Diameter 100, because it is passing through the origin and then it is reaching 100. And then C will be equal to 100 by 2 equal to 50. That is how you will take the value of C. It is simply, if somebody is saying Q equal to 100, you simply say C equal to 50, just half. No need to remember all this. Of course you have to know the concept, but directly you make it half if it is only unconfined compressive strength. So now you have the value of 50. Now simply substitute AB B square C and C into AB, 50 into 9 into B square, plus AF 40 into B, 0.7 into 50, right? 50 into 0.7 into 40B. Can sum of and this Q is also given. What is that? 632, and 9 5s are 450 B square plus 7 5s are 35, or let us go with this like this, 5 4s are 2, 2000, 0.7, I think 1400. Is it? 0.7 of 2000 is okay. I think this is correct. Can someone of you solve and tell me the answer? Can you listen, one of you, any one of you? Do you have the calcia or should I do? Can someone of you please tell me? I am also solving here. So before writing I am almost done. Can someone of you? Okay, I think so. Shall I go with answer? Okay, it's 400. Sorry, it's 0.4. I have directly given, but it's 0.4. Answer is 0.4. So here if you see, everything is given 50 kPa, kilonewton per meter square, 50 kPa, L is 10, all that is also in meters. So everything is in SI units, that means this is meter. But what is asked? 0.4 meter. What is asked in mm? So 0.4 meters equal to 400 mm. So I hope everything is clear. Is it fine? So we have solved 3 questions now. I hope it went well. I hope you enjoyed the class. Okay, so shall I end the meeting? Do you have any doubts? You can ask any doubt if you have. Hello, I hope it is clear to everyone, as there are no doubts. So you can leave the meeting. Thank you. Thank you.
Yes, sir.
Yeah, tell me. Yeah,
Sir, in the earlier, as I asked you a question on the complexion curve, sir.
okay.
What is the purpose of, sir, what is the zero air void line, sir? Why you are drawing zero air void zero void line? What is the purpose of that line, sir?
Where? In the compaction.
Yes, sir, in the above compaction, you are drawing
Yeah.
zero
Yes, I understand.
air void line.
See, it is simply theoretical representation that zero air void line. See, there are no zero voids. There is no condition of soil where voids are zero. Okay, void ratio is zero or voids are zero. It is simply a theoretical representation. Now, if you observe that no compaction curve is touching the zero air void line. Have you ever seen any zero air void line is touching the compaction curve? It is only left side of the zero air void line, always. It cannot touch, it cannot go beyond the zero air void line, because there are no zero void condition. Because the voids can be filled with completely some void can be filled with water, or some void can be filled with air, but there cannot be a situation where soil, and there is no need to worry about the zero air void line. It is simply theoretical representation. Okay. Okay, so any other doubt? Shall I end the meeting?
Yes, sir.
Yes. So thank you guys. Okay, we'll meet in the next class.